Well, good afternoon. Welcome once again to COMP621 Web Security. Today's topic, hang on, let's do this. There. Today's topic is web security or authentication. Well, it's web security, but yes, okay. And we have, oops, there. We have a quote. Take a good look at this because we're going to talk about it later on. Okay, yes. Well, that's Bruce Schneier, by the way, is a cryptanalysis. He's written several algorithms for encryption, the Blowfish algorithm, a couple others. He's written a couple books too. Okay, moving along. So authentication is the whole concept of proving that you are you. Since generally systems want to know who you are because many things are oriented towards individual users. So authentication is proving that you are the person you say you are. Now that differs from authorization. Authorization is once I know who you are, what are you allowed to do? We're not worried about that at this time. We're just worried about trying to figure out, are you really who you say you are? This is an extremely important part of web security because if you can fake the authentication system, if you can hack into that and sign on as somebody else, well, then typically you can access almost anything. Usually, if you are logged on, you can access your information and nobody else's. So if you can log in as somebody else, you can access their information. And of course, if you can log in as an administrator, you've hit the jackpot because usually, or sometimes administrators can see everything. So you want to be able to make sure that you can provide a secure login so people can't get in and see the information they're not supposed to see. Most systems do this in a very simple way. Most systems use, user IDs and passwords. We'll get to that. First step is usually identification. You say who you are, either your name or your email address or your user ID. And then you prove that you're you by doing something. And we'll talk about all the somethings you might do, enter a password or whatever. Passwords are very common. Most systems require you to enter a user ID followed by a password. Alas, that doesn't work really well. And we'll talk about the problems with passwords. Actually can be kind of expensive to manage because you have to worry about the lost password or forgotten password problem and passwords that people might lose, meaning they might go out and become public knowledge. Some of the issues there, I have a list. That list is not in the order in which I'll talk about, but I will talk about all those topics. Forgotten passwords, guessing, spoofing, compromise the password file. All these are issues and more. We'll talk about those today. Okay, the first thing I want to mention was password guessing. Okay, so you don't know what the person's password is. You just want to guess. You just want to go out there and run a program and try it. So there's basically two different approaches to this. The one is the exhaustive search. That's kind of difficult. Exhaustive search is try all the possible characters on the keyboard. Well, there are 26 letters. Upper and lower case is 52, plus the other numbers is 62. And it turns out, I counted this afternoon, there's 28 symbols on my keyboard. So 62 plus 28 is 90. So there's about 90 characters on the keyboard that you can enter. If you wanted to guess just a 6-letter password, it would be 6 to the 90th possible combinations. If you're lucky, you'll get done in half that time. But it's still, that's a very large number. What works much more effectively is a dictionary attack. Instead of trying every possible combination of letters, numbers, and symbols, you can try just the popular ones, just the ones that people tend to lose. It's called dictionary attack often because people look in the dictionary and take all the words in the dictionary and all the names and the commonly used passwords and try those. Turns out in the English language, I believe there's some 300,000 possible words, of which almost nobody knows more than 120,000 or so. So you can go up and try all 300,000, which isn't a very large number compared to the 90 to the 6th power. Yeah, so you can try those. And so if you can't prevent somebody from accidentally guessing, you're probably going to be able to compromise your system. Turns out that the most popular passwords are very popular. 1, 2, 3, 4, 5, 6 is the #1 winner. Was depending on whose websites you look at, what study is done, somewhere between 3 and 4.1% of all the passwords in the world are 1, 2, 3, 4, 5, 6. And the list I give here of the top 20 passwords accounts for about 10% of all the passwords used. Now, these are passwords that allow letters and numbers and that sort of stuff. Commonly, you'll have systems that only use numerical pins. If you are using your ATM or something like that, many of them only have numerical numbers. Well, numerical numbers, yes. Turns out that if you have a numerical pin, then the top 10 pins represent 50% of all the pins used. In other words, people have gone out there, looked at password files and measured which ones are used, how frequently each one is used. It turns out the top 10 of them represent about 50% of all the pins used, which, if you think about that, okay, you want to guess your way into somebody's system. And let's say the system only allows you to make 10 guesses before it kicks you out. Well, even with 10 guesses, you have a 50% chance of getting in just by guessing the top 10 most popular pins, which is not real good security. Okay, how do you know a good password when you see it? Well, long is good. Longer the better. If you make a very long password, it involves more characters, more words, more things for somebody to guess. Also, if somebody's just looking over your shoulder, it becomes more difficult for them to remember it. So long is good. A lot of systems want 8, 12 is good, 16 is better, and so forth. Whatever you can type in a reasonable amount of time and remember. Use all the keys you have on your keyboard. Don't just stick to the letters. Notice you've got lots of keys. Like I said, I can count 90 things on my keyboard. Now, you have to watch out because some devices have input symbols or keys, you might call them, that are not on other devices. I looked on my phone and I looked on my keyboard I have right here, and turns out that I think my phone has every character on my keyboard and more. So if I was to use a symbol that I find in my phone that isn't on my keyboard on my desktop computer or my laptop, it's going to be hard to enter it if I want to log in to my laptop. So use a lot of them, but be careful about those really weird ones. I had a friend who, just to get really secure, noted that you can enter any of the 256 different ASCII characters by pressing the Alt key and then 3 decimal digits. And that'll give you any character. And so he had a password that included a character that wasn't on the keyboard. That was pretty secure, except he couldn't enter it on many devices. Okay, and again, if you want to avoid a dictionary attack, don't use words that you find in the dictionary. I'm sad to say that years ago in an organization where I worked, we changed the root password every couple of weeks. And so at one of our daily staff meetings, we'd open the dictionary, flip through, point at a word, and if it was long enough, that was the password of the week. But it was in the dictionary. We don't do that anymore. Okay, now you want to use a unique password for each application. That's a challenge because most of us sign in here, there, in many different places. And so you have to have lots of different passwords. And it is a challenge or how to keep them all. And that brings up the next issue is be careful where you store them. Unless you've got a really interesting system, you be hard to remember 24 different passwords. And then if you can't remember 24 different passwords, where do you put them so that nobody else will be able to find them? Another thing you want to avoid is commonly used patterns. Oh yes, by the way, I got this from the McAfee website along with these suggestions. They told me that, yes, it turns out that these patterns are pretty common. It's upper, you can see from here, the uppercase letter, 5 lowercase letters and 3 digits. I may have done that before. In the popular passwords, you can find that there are some of those. Yes, Aaron 431. That's not uppercase, but that's kind of the symbol. Turns out that this is done pretty common. And then a couple other variations, 1 uppercase, 6 lowercase characters and 2 digits. These are all trying to make passwords that are 8 characters long. Okay, now, even though you have a nice long password, some systems will sanitize the password because they're worried about SQL injection, which you should not be worried about if you do this correctly. You shouldn't, if you are doing the proper security to avoid SQL injection, then it doesn't matter what characters the user enters. But some systems still want to go, oh, they entered a greater than sign or less than sign or something like that. They better take that out. Some will reject it, and others will simply remove those characters. So you might have a long password that involves a lot of weird characters, but after the system sanitizes it, it becomes very short, so it's not very secure. Okay, so let's try something right now. Let's make an effort to think about this. How can you remember good passwords? There are several techniques. Let's think about this for you. We're going to break into groups. I see there are 17 people here. I'm going to break us into 4 groups and think about it. Somebody keep track of the ideas, and I'll ask you when we get back and see what kind of ideas you have. Anybody have any questions about this idea? Everybody's okay, ready to roll? Then here we go. Where is that? Okay, breakout room. Sorry, sometimes Zoom hides things on me. And we're going to create we'll go groups of 3. So there it goes. And I'll bring you back in 5 minutes. Mr. Smith, wake up. Your teammates are waiting you. Was that useful? Did you just talk about the weather? What you doing this weekend?
Well, it's nice weather, so I think the only thing I really talked about was like diceware passwords. Where you like randomly take stuff out of a dictionary and string the words together.
Mm-hmm.
I've heard mixed things about the security though.
Well, you can think about what's the probability of somebody being able to guess that if you picked 100, if you had,
Yeah.
well, if you have 100,000 words and you did that, you get a pretty big number pretty quickly.
Yeah, but the thing is, if you got a dictionary, it would be easier to figure it out. I mean, the way I've always kind of thought of that would be an easy way to make it a lot stronger is to create a random word in the middle of it somewhere, and just basically make a random sentence with that or and that one of those words would be weird.
Okay, well, we did have, let me just write these down if people have suggestions. Concatenate random words from a dictionary. I'm gonna just get strange here and we'll.
That was similar to what mine was. You were able to like their crypto wallets use that to create seeds for creating strong secrets.
Okay, so can you repeat that in a way that I could write down, or is that just gonna just take the same thing as Justice said?
Take the same thing.
Okay. What other group? Let's see. How about the group of Shaver, Edison, and Smith? Anybody there think of anything?
That was me.
Oh, okay. Sorry, didn't. It's hard
No
to tell.
props.
Hard to tell who's took. Well, in that case, we'll pick on the L Battle and Banks group.
We had came up with 3. One of them was to write a sentence of 16 characters and a number.
Friday's sentence.
Write a sentence. And it kind of went with our second one, which was a popular catchphrase that was at least 16 characters. And then put a number from your life somewhere in there. Like something you say day to day. And then our third one was take a favorite book of yours and choose a sentence out of the book and put the page and line number.
Oh, that's interesting. Oh, I can't spell today. Favorite book. All right. Hey, that's pretty good. How about Holmes, somebody, and Tamarin? Hello, Holmes, Abadari, and how's it been?
Yeah, so we can use special characters or symbols, and the capital
Special
like
characters.
percentage or hash or dollar, something like that, or brackets.
Okay, does that make it easy to remember?
But as maybe
I don't know if everybody
he
saw
can explain. He just said something about BitLog that can save our password and we can store that safely.
Right, that storing it safely is important. I think I just mentioned that.
Mhm.
Okay, how about Brown and Roseboro, Williams Roseboro?
So we said favorite movie character or TV character with a number.
Oh. All right, that's pretty good. I'm running out of space here. Any other ideas? Did I get all the groups? DeWitt and Ellsbury. We actually lost 3 people when we did this. 3 people signed off and didn't return. I don't want to do this. Just that makes me hard to believe they're just listening to old Dr. Williams is more interesting than that. But okay, so we have some ideas. Well, of course, I have ideas. So unless anybody else wants to add something to your list here, it's a good list. So we have concatenate random words for dictionary. Write a sentence of 16 characters, use a catchphrase with a number, favorite book sentence, add page and line number, find your favorite TV character or so, and add a number. All right, good deal. Then let's go on and take a look at some other ideas I've had. All right. And here are other suggestions that I've picked up along the way. As you said, create your password from a sentence. I think somebody suggested this. In other words, think of a sentence that you can remember. It can be from a favorite book or something. That's a good idea. And then use the first letters of the sentence to make a password. So here's my example. My very educated mother just served us 9 pickles, which we used to use to remember the order of the planets, by the way, until Pluto disappeared as a planet. And now I'm not sure what we do. I don't know what school children's learn. Okay, then you have to change some of the letters to numbers, which is easy. Some things like 4, in English 4, or 2, it becomes a 2, and such things like that. And then make some of them uppercase. Probably not the first one. That, as we saw, that's a pattern. Don't make the first one, pick another one and make uppercase. So from my very educated mother, I could make MVE, MJSAUMP, or in this case, I changed the 9 because it was written as 9 here to the number 9, P, and then I added a question mark because I'm not sure, because Pluto is no longer a planet. It got demoted to a dwarf planet. Okay, so that's one way to do it. Another way it's used is to treat your keyboard like a constellation. That is, look at the grid and then draw pictures on the grid of by clicking the characters in particular order. You can make a big circle. You can put your initials or your buddy's initials or something like that. You have to make sure, though, you don't avoid the usual patterns. A lot of people, click the keyboard in a straight row, QWERTY. They just put the kingdoms on there, 1, 2, 3, 4, TY. And that's how, of course, how 1, 2, 3, 4, 5, 6 is so popular. It's easy to type. So avoid those. Okay, so that's before we get back to that. Any other thoughts on remembering passwords? And as somebody mentioned, you got to keep them in a safe place because you have so many of them. If you just, well, obviously, as it showed in an earlier slide, writing it on a sticky note and sticking it to your monitor is not real good. And you would be surprised if you wander through offices, how many passwords on sticky notes you will see. It's really common. But don't do that. Okay, so other topics, shoulder surfing. That's the idea of somebody looking over your shoulder while you type in your password. Actually, I realized after I put this picture on, it's not a good picture. He's looking at your screen. You want somebody to be looking at your fingers and seeing where you are typing. Because if you look carefully, you can probably figure it out. In fact, in an organization where I worked, where we again used to change the root password every couple of weeks, other people in the organization who did have a need to know the root password, we didn't tell them the root password. Every now and again, if we had to use the root system, we were over at their office and I logged in. The game was to look at my my fingers and see if they could figure out what I was typing. So you try to type it as fast as you can. Of course, if you made a mistake, then you had to type it again and give them more chances. Turns out, with a little practice, you can watch the fingers and figure out what somebody's typing. And I was looking on the web. They recommend be careful about this at long range with binoculars. I suppose if you've got a window in your office, they can see your keyboard. They could watch that. What makes it really challenging is if somebody pulls out their phone and surreptitiously videos you're typing your password. If they video it, then they can go back over the video, run it nice and slow, look at each character and figure out what your password is. Not only videos, but security cameras. Sometimes the person on the other end of that security camera may not be all that secure. And so these are things to watch out for. And this is, unfortunately, rather common. Okay. We talked about brute force password search. And again, typically, brute force password search doesn't try all possible symbols. Instead, try use the common passwords first, because after you get through a couple 100,000 of those and don't find it, then you might try something else. But the probability of finding it in the first 100,000 most common passwords is pretty good. Now, you don't have to write the program yourself. There are tools to do this. There are several tools out there that will automatically do a password search for you, either online or against a file. And if you're allowed to just try it as fast as the network will go, you can usually get many in. And if you want to do better, well, make it in parallel. Have lots of computers or logging into multiple different the same system through multiple connections. You can get lots of them. Now, in order to prevent this, some systems limit the number of incorrect password attempts. In other words, after you make a small number of incorrect password attempts, it stops you. Apple phones are famous for their 10-try limit. After 10 tries, it erases your phone, which I suppose does keep it secure, although that's probably not a user-friendly option. So a lot of systems will count, and after so many, they give you a warning, and after then they'll shut you off. Now, sometimes when they shut you off, they'll just make you wait for a few minutes. That's actually sufficient. Just make them wait for 5 minutes. Don't tell them how long you can make them wait. Just make them wait for a little while, and that really slows down a automated password guesser, because otherwise they can be doing thousands a second, and if you make them wait for 5 minutes every 5 incorrect guesses, it's going to take forever and ever for them to get that done. Another feature is also, when a user logs on, tell them how many failed attempts were made on their account. So normally, if they keep answering correctly, no message. But if they've been a mistake or two, sometimes it's you did it. I just typed my password wrong. I know that's me. But if you log in and it says there's been 10,000 some failed attempts on your password, something's up, and you better do something. Okay. Now, in order to get around, there are ways of getting around this limit. And sometimes the password limit is kept in a cookie. The cookie may have like failed attempts equals 1 or failed attempts equals 2. So you could either just change the cookie so that so it's always down to failed attempts equals 1 or something like that, or don't send the cookie, and it looks like you're logging in for the first time from that computer, and it doesn't know. That way, you don't even have to be able to decrypt the cookie. You just don't send it. So every time you log in, it looks to the system like you're logging in from a new computer, and therefore, it doesn't think you're going to max out. It's best to keep the count of incorrect password attempts in the database along with your passwords and usernames. That way, it's on the server. It doesn't get exposed to the user. Anytime you expose information to the user, there's a potential for it to be changed and attacked by the user. So try to keep things internally. This also comes around with the concept of reporting. It's not only should you keep track of them, but if you find something going on that looks wrong, if you had 10,000 attempts on somebody's password, you ought to do something about that. You might want to inform a human being. And, you can send emails, text messages, put up a notice on some system, tell somebody that there's been a lot of incorrect actions on that one, and that they probably want to take some action. Now, a lot of web servers keep track of how many pages are actually, they keep track of every access to the website. It tells you, what pages they were going up, all the requests. In fact, they usually just save the request line. So it tells you it was a get on this URL. Sometimes they save not only the web page, but all the parameters. So if you go get Williams.com and get the EU/, whatever question mark, user ID equals this, password equals that. Well, the whole thing is stored in the log. Well, that's not real good because anybody who can see the log can see what people are logging on as passwords. You get everybody's password that way. So you want to make sure that you don't do that. A good way to avoid that is use a put instead of a get. With a put, the data will be sent as far as data request. If it's a get, it will appear in the URL as parameters. If it's a put, it will appear as data in the request, and the data is not generally logged. And of course, probably shouldn't have to be said, but you should use HTTPS and not just HTTP in order to encrypt the messages as they go out. Obviously, you want to encrypt all the password attempts. Okay. Despite our efforts to make passwords we can remember, people forget them. And that turns out to be a very vulnerable spot because the attackers can go out and try to go through the changed password system, whatever it involves a human or involves another web page, and try to change it to something that they know and you don't know. According to information I've read, some of these changed passwords pages are not nearly as secure as the regular enter your user ID and password system. And often they'll ask you some sort of questions, some questions that you entered before. Turns out that social engineering can get around that. I don't remember what, but I watched a movie once and they were talking with this millionaire and asked him a bunch of things. Oh, did you have a dog? Yeah, I had a dog when I was a kid. What was the dog's name? Well, it turns out that was one of the bank questions, and they got all the information they needed to log in as him. There are several ways to get around this. Now, you want to be able to get around this problem without causing issues, things that you can forget. And everybody's asking you, like, what is your mother's maiden name? Well, it may not be difficult to find out what your mother's maiden name is. So you probably want to not use your mother's maiden name. What I find works well is create an alternate identity for yourself. Create another, alter ego, somebody, another person who's got a different paternal mother's maiden name, father's, mother's maiden name, all the, birthdays, all these things, all the information they're going to ask you. Think about it. Sometimes find a popular person that you know, pick a friend that you know, and you know all this information about, and use their answers because it won't be related to them, it'll be related to you. Anyway, we have to make sure it's something you can remember, but it works pretty well. Then you can answer these questions using your standard answers, even though no one's going to know your standard answers because they aren't true. Which also gets around to a privacy issue. How much information do you want to tell these organizations? A lot of these big corporations may be just as scary as the hackers. Okay. Typically, when you log in, you enter your user ID and password. If an attacker is going to try, they not only have to know your password, they have to know your user ID. Well, sometimes this is really easy. The user ID is something like your email address, and everybody knows it. Other times, you get to select your own user ID. And so that makes it much more difficult for an attacker because they not only have to figure out what your password is, but they have to figure out what your user ID is. Now, systems that ask you for user ID and password have to be careful about the error message. The error message should not say, oh, unknown user, because that tells the attacker it wasn't the password that was wrong, it was the username that was wrong. And also, if they just enter a user ID and no password, well, of course the password's wrong, but they're, see if it gets a bad message. So tell them only one. Tell them, there was an error. You don't have to be specific. They'll know that it's an error in either the user ID or password. Just tell them incorrect. Please enter it again. And while the error messages may sort of look the same, people who studied security systems find that sometimes there are subtle differences in the message. That if you look at the HTTP message, if you look at the page that's sent, there is a slight difference between them because they come out of different parts of the program. Someplace found a bad user ID, someplace found a bad password or whatever, and they send different messages even though they kind of look the same. So be careful about that. There's also a problem when you set up initial passwords. A lot of big organizations, the company will create a user ID and password for everybody in the organization for something. And they'll try to create an initial password with information that only you and the organization should know. Of course, that's not quite true because other people may know that information too. And then you have to send it to the people. Well, of course, if you're giving everybody an email and password, well, you can't email the information to them because they don't have their email address. So you have to get it to them in a secure way. A&T has this issue. When you are a new student, A&T is going to give you a username, an email address, and a password. And so that they also create the, can anybody tell me, what are we using these days for initial passwords? Some of you must have got this not too long ago.
I think it's the first 4 characters of your user ID and then the last 4 of your
Banner
Aggie banner.
okay.
Yeah.
Yes, okay, that's been popular at A&T for quite some time. Yes, in fact, it used to be, by the way, we went to banner numbers a decade ago. Before that, it was social security numbers, which had all sorts of privacy and security problems. But now it's the first. Anyway, it's sometimes not too hard to figure that out. They are not random in their designation of banner IDs. They're rather sequential. And so sometimes you can guess. And of course, if you can guess and get there before the student does, well, you can log in as them and then change their password or not. Some systems require you to change your initial password. So they give you this automatic password, and then you are required to select a new password. Others do not. I've known students who've gone a long time using their default password. Okay. Another feature you'll see on many websites is this remember me box. There's a little checkbox that says, oh, remember me. And if you check that, then you will not have to enter your user ID and password the next time you go there. That seems like real convenient. And I suppose convenient it is, it may not be real secure. Typically, that's implemented with a persistent cookie. And as we all remember, persistent cookies have an expiration date that's sometime in the future. You can make them rather lengthy, like a year or so. And then when you go to log in again from that computer, it will send that cookie to the server. The server looks at the cookie and says, oh, yes, I know who you are. I don't need to ask you for user ID and password. I know who you are. So that works. That doesn't work well at all if you're on a public computer. That is, if you're at the library or something using the computers, never check the box. Because if you do, and somebody else wants to log in that site, they'll log in as you. That's not real good. And if you were paying any sort of attention when we talked about cross-site scripting or cross-site request forgeries, you know that we can steal cookies. If you can steal somebody's persistent cookie for that website, then you can log in as them without having to enter the user ID and password. Replay threats. This isn't a real problem if the information is sent over HTTPS, because HTTPS creates a new encryption key each time you create a session. But some other systems do not use HTTPS, and they have the problem of replay. A replay is when somebody records the message going across and then later plays it back. So assume you're correct, you are correctly entering your user ID and password. They record that message, and later on, they go to that website and then they send those messages again, the correct user ID and password, even if they're encrypted. Then if they were correct to start with, then they're correct when they try to log in as you. That's the advantage of HTTPS, is that it's a new encryption key every time. And even if they record it, you try to play it again, it won't work. Some sites you go to will try to help you ensure that you've gone to the right site, because phishing attacks and other attacks will try to lead people astray to a false copy of the site. And it looks exactly the same because it's very easy to copy the HTML of a web page and then put it on your site and make it look exactly like the site you're trying to copy. And so some sites, first thing you do is you enter your user ID, and then it goes to a new page and it tells you the phrase that you have entered earlier. And it tells you your secret phrase. And so if you go to log in and you enter your user ID and it comes to the next page and you don't see your secret phrase, well, don't enter your password. Something's weird. Back out and log in again, typing in the URL correctly. Now, this, of course, is a pretty worthless effort if somebody knows your user ID. So if your user ID is common knowledge, like your email address, then this doesn't do any good because somebody could just type in your user ID and say, there's your phrase. And it does have the problem, as we mentioned, error messages should not tell you whether your user ID or your password is wrong, which one is wrong. And in this way, you get to know whether the user ID or the password is incorrect. Okay, CAPTCHAs. You've probably seen these annoying things before. I've learned what CAPTCHA stands for, completely automated public Turing test to tell computers and humans apart. Basically, it's a method of trying to keep computers from creating accounts or logging in where the website only wants real, honest humans to be there. So they have this sort of reverse Turing test. If you remember a Turing test, a computer is trying to make it difficult for you to tell whether it's a computer or a human. This is where you're trying to make it difficult to tell whether it's a computer or a human. Okay, or to tell the difference. And again, we're trying to keep automated systems from logging on. Okay, there are several different ways to make a CAPTCHA. I mean, we always see these bent up characters that merge together with some swirly background. Other ways to do it, you can ask questions that humans can answer, but computers may not know the answer. You want something that the humans can easily answer. Most humans can read these these sort of VZPK2Z. Yes, but it turns out that's relatively difficult to do for a lot of computers. And also, you can change up the CAPTCHAs so they're different all the time and don't rely on the so attacker cannot rely on what type of CAPTCHA you're going to ask. There are accessibility problems to this. Some people who use computers cannot see very well. Computers have been a real boon for people who had visual impairment, because before they couldn't read things. Now you can get the computer to read things to you, but they may not be able to read the CAPTCHA. So you have to have alternatives. There are audio CAPTCHAs. I guess I haven't tried one, but I see them sometimes. Click here for audio CAPTCHAs. Another alternative is, again, common sense questions. What color is the sky on a clear day? What color is grass? Other such questions like that any human being should know, but it's going to be hard for a computer to know that sort of stuff, given the nearly infinite range of questions that you might be able to ask. There are image recognitions; those are very popular. Click the pictures that have a motorcycle in them, or something like that. Problem with these sort of systems is they are sometimes difficult to automatically generate, although that's part of why they're useful. If they were easy to automatically generate, then they probably would be easy to guess. Now, there are ways to try to circumvent CAPTCHAs. Optical character recognition is getting better and better. So it can sometimes even pick out the characters, even if they're kind of sloppy, mixed together, overlapping and stuff. Some of them are getting really good. And then you can ask humans. You could have a system that's going out there hacking, and every now and again, when it gets a CAPTCHA, flashes up to a human being who answers the question and then goes away. There's a really interesting way I saw is that you can have a game and have people have a website where you have this game and you're going out, picking up captchas from all over the place and displaying them on your website and see if people can, how many they can answer in a given amount of time. So you have the public answering them for you, and you keep this as a database. And most of the systems only have a limited number of different captchas they can throw at you. And so you go out and you ask, have humans answer them for you. And then if you get the identical captcha, you go and see, what did humans tell me that was, and answer it that way. So it's also interesting that there was remark on one of the websites that the circumvention of captchas may violate the Digital Millennium Copyright Act. That was passed, a decade or more ago, to write copying of things. There's been quite a bit about that when it first came out, but I believe there's laws against trying to circumvent certain security systems, and this may violate that law. But then again, you have to catch them. Okay, moving on. Once somebody's entered the user ID and password, the server has to check and see, is that the correct password? And so almost all the systems contain a file or a database of user IDs and passwords. Commonly these days, it's a database, but that doesn't mean you can't get information out of it. If somebody gets the database of all the information, well, if you're keeping all the passwords and user IDs in that database, then they've got everything. I mean, imagine somebody steals your password file and they have everybody's password. How do you solve that? That's the really only way to do that, is tell every one of your users, oops, you have to recreate your password. And how do they validate who they are? Because they could type in their old password. Of course, an attacker could type in their old password because they've stolen that. That's a real tough problem. You don't want to get into that situation. It used to be that the Unix system kept a file of the passwords. It was /etc, etc, /password, and it contained the user's username, a couple other information, and a hashed version of their password. Well, it turned out that wasn't a very good idea. That it didn't take long for people to do rainbow attacks. That's where, or they take all the common passwords, they run them through the hash algorithm, so they get a hash of all the common passwords. And then when they have a hashed file, they just look up that hash. Do I know that? If they have seen it before, then they know what the password was. It works really well. So basically what they store, way to store it, of course, is use a strong hash function. We talked about those earlier, like, well, SHA-1 is very common, but it's kind of old and insecure. SHA-3 is much newer, more secure. There's others. You can find whatever your favorite hash algorithm is and use that to take the text of the password and then run the hash algorithm on that text. And now you have this string, maybe 256 bits, that looks random. And if it's truly one way, if somebody knows the hash, they cannot figure out a password that goes to that hash. And that's the whole concept of these hashes. You can't reverse them. Given a hash, it is very, very difficult to find text that will create that hash. And so if the hash is known, then somebody can't log in because they can't get a password that meets the hash. So if you store it as a hash, of course, whenever a user enters the password, you hash it, and then you compare it to the hash value. And I might note that it doesn't matter what text they enter all sorts of SQL injections or cross-site scripting attacks in the password. It doesn't matter. You're going to hash it into random bits, and it's totally it's safe at that point. Okay. You can even make it more challenging because, again, there is the rainbow table attack. That is, somebody's taken the top most commonly used passwords, they've hashed them using whatever algorithm you are, SHA-3 or whatever you like, and they've saved all those in a big database. So now they have all the commonly used hashed passwords. And so whenever they come up to a hash, they look in their database, see if they can find that hashed value. If they can, now they know what the password is. Make that more difficult when after you hash the password, you have the hash value, you then make a random number, append it to the end of the password. Now you have to keep that random number in your database. Your database has the username, the hashed value, and the random number, often called a salt. And then, so when somebody logs in, you hash their password, attach the random number for that user ID and see if it matches. But this way, if somebody wants to, gets hold of the data, it makes it more difficult. They can't just look in their big rainbow table, because if they add a random value to the end of what's being hashed, it changes the hash and they can't figure it out. Well, makes it more difficult to figure out. Another sneaky attack that's been used is you go to a public computer and you look at the website. What does it look like when you go to log on? It's really easy. Just capture the screen, or and then you make a program that displays the identical information along with the enter user ID and login stuff. And then somebody comes up to log in. They press the button. Your program is running, not the system. And the program displays the user ID and login, enter. People type in their user ID and login. The program stores that away and then prints a fake password error message and then terminates and logs off. And so the user sees this, oh, bad password, system goes blinkety blink, and suddenly they're back into the real enter user ID and password message. And you have their user ID and password. For a while, Microsoft Windows was avoiding this problem, because in order to get the user ID and password screen, you had to press Control-Alt-Delete. And Control-Alt-Delete cannot be captured by a program. It's captured by the operating system. So a program, even if a program submitted, showed the screen, pressing Control-Alt-Delete got around it. But they don't do that anymore. So made it user-friendly, but more dangerous. Another very popular way to log in is to log in through another system. You might want to log in with Google or Facebook or Amazon, or there's at least a half dozen that you can log in. Frequently, often you'll log in, like I log into Google and I use the Chrome browser. And then if I go to a website that wants to know me, they'll say, oh, just click here to log in with Google. There are several systems that do that. There's the OpenID system and there's the OAuth system. Those are the two very popular systems for shared authentication. They're protocols that allow you to work with an organization that will then validate that you are. In other words, say you're using Google, you can, okay, so you say, I want to use, so the server will send a message to Google, say, what about this person? They'll say, oh, yes, that's who they are. Or actually, I think the user sends the message, sends back a token, sends the user, they go, ah, yes, it says that you're you. I have a video here. So you don't have to watch me all the time. Let's watch this. This is from Google, and it explains the Google login. So this is 4 minutes and 14 seconds. So let's give it a shot. Oh, wait. How do I stop this? Could you hear that? Hello?
No,
Could
we
you
can't hear it.
What? You couldn't hear anything?
No.
Ah, yes. Okay, stand by. There's a button I have to. Okay, I'm going to stop sharing my screen for a minute. I know which button I have to press, which I didn't press. Yes, share sound. Okay, no, we don't want to see this. Back up a couple slides. Okay. Can you hear that?
Your name?
Takuo,
Your password?
1, 2, 3, 4, 5.
No.
QWERTY.
No.
How about admin?
No.
What's up, guys? What's happening?
Do you know this guy?
Sorry, I should not have pressed that button.
Guy? Sure, he's Takuo. He visits me every day. Do you need the ID?
Thanks. Can I get in now?
Yeah, go ahead.
All right. See you tomorrow. We all know that passwords can be a pain. Every website asks for one. Users have a ton of them they can't remember, or even worse, some users have 1 or 2 passwords, reused across various websites and apps, which could be a big security risk. This is not fun for users or developers. My name is Eiji, and there's a handy and simple solution to this issue called federated login. Federated login means that user authenticates using a third-party identity, usually without re-entering credentials or profile information. Google Sign-in is Google's take on federated login and is designed to be as easy as possible for you to implement and for users to sign in. Let's see how it works. Here's the sign in button. When the user taps on it, a sign in window appears. The user chooses an account and then signs in if he is not signed in already. The user allows access to profile information. Now the pop-up window closes and the user is signed in. Notice that the current best practice for asking permissions is incremental authorization. This means that rather than signing in and requesting user permissions at the same time, you should first sign your user in and request for permissions only when they are needed. Check out my authorization video for further details on this. Now let's take a look at how to implement Google Sign-in in just a few steps. First, head over to Google Developers Console, create a project, add a credential, configure a consent screen, and create a client ID. In HTML, add the client ID to the head section using meta tag. Then load API.js. This is the core of Google JavaScript library. When API.js is loaded, call gapi-load to import auth2 module to enable Google Sign-in. Then call gapi-auth2init to initialize. Once these are done, you are ready. The next step is to render a sign-in button. The most generic option to do this is to use a custom button. Put an HTML tag and use regular CSS to design the button. Don't forget to read our guidelines for designing the button. You'll also find the button assets in the same doc. Add an event listener and invoke sign-in when the button is pressed. The sign-in function returns a Google user object. Use it to get basic profile information such as username, email, and the profile image. Finally, users can sign out simply by calling sign out. Review our sample code here for a more detailed walkthrough. Okay, this was the basis of authentication using Google Sign-in. But what do you do if there's a server involved? Or how would you access the Google APIs on behalf of the user? I will talk about these workflows in the following videos in this series. Thank you for stopping by and stay tuned.
Does anybody have any questions about the video? I'm sad to say, I tried to follow their instructions. Well, it ain't as easy as they seem to make it look. First thing, they have a web page. They say, oh, simple, just do step, 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 and you have it. Here's some sample code and everything. And the first thing is go here and create, go to this web page and click on this. We go to that web page and that isn't on the page. And yeah, I got lost wandering through the Google universe, and it wanted to approve my website and everything. So I finally lost it. Okay, well, moving right along. There are other login systems that have been around for a long time. Kerberos is one. And I have recorded a Kerberos login. Hey, get your popcorn sometime and watch my video. It's pretty short. I think it's about 11 minutes long, or something around that, 10 to 15 minutes long, detailing Kerberos. So I won't explain it here. Just to say it's been out there. It's a secure method. It still requires user IDs and passwords, but it treats them securely. Interestingly, it doesn't send the user ID and password to the user. Instead, it uses the password as an encryption key. Okay, there are several ways to tell if a person is who they say are. Some of the basics are it's something you know, like your password, or something you have, like a ID card or where you are. Those are things that are relatively easy to do on a web. There are others what you are and what you can do that can be implemented in some systems. They may not be real web security aspects, although with more people using phones and phones having much more functionality than you find available through HTML on a desktop, they're becoming more popular. Multi-factor authentication is becoming very common, using more than one way to determine if a user is that person. In other words, instead of just asking for the password, you do the password and something else that they have to do. So it makes it much more difficult for a hacker, because the hacker might get your password, but they not know the rest of the information. There's a Google Trust Score system that looks at several values. You can do facial recognition, location, which Wi-Fi network you're connected to, and other things, and then look at a bunch of them. And if several of them seem to match what Google thinks it should be, it lets you in. If, though, you don't get a good enough score, it's going to have to ask some other system. So multi-factored, again, is the idea of asking for multiple means of security. I have a little video from the Pixar cartoon Incredibles.
Edna mode. And guess.
I like that. That's multi-factor security. A multi-factor security can use several things. The most popular one that's being more and more commonly used is to have the site text your phone and send you usually a numerical value. And then you take that numerical value and enter it into the web page, the login page. So you enter your user ID, password, press, enter. It comes back and says, enter in the number that you've received in your phone. So you get a text message and you enter that. It can be a text message or a push notification. A push notification is where it sends a message out to your phone, not necessarily a text message. Google does this because, if you have an Android phone, Google owns your phone, and they can just pop a message up on your phone. Other things you might have, some of which are easier to implement on a non-web oriented system. ID card, do you have the proper card? Particularly smart cards that, USB, something that has information that you can see. There are USB systems where it has an encryption engine inside, and you send data into it, and it sends the encrypted value out. So you never see the encryption key, you never see how it's done. All you enter something, out comes the encryption. I somewhere have a not a USB, but a ring that you might wear on your hand. And if you click it into a reader, it does the encryption. So you can wear your ring, and then if you need to access something, you click your ring into the reader, and it will do the encryption, and then you can encrypt the value for security. Another very common way to do security is digital certificates. That is, have somebody have a digital certificate. We talked about digital certificates before. Instead of just the server having them, the user can have them. And HTTPS can be configured to require a digital certificate on the client side. And of course, these are all things that you use with some other method of authentication to make it a multi-factor authentication. Another commonly used practice is to limit login to some specific location, either the IP address, so that you have to be on a certain network, particularly if you have a network that has local network addresses. The university has a network address translation device, as does my house. And so there's the external IP address on the outside, and then it comes into the internal network. It changes the IP address. You can require that the access come from the local address. In other words, it has to be from this particular IP address, or you're not going to let them log in. A&T does that. A&T, the administrative banner system, you can't log in unless you're on the network. I'm not sure how a VPN impacts that. I haven't tested it. Then another way is to do global positioning. Since phones typically have GPS built into them, you can determine where in the world this phone is, and if they're not where you think they ought to be. If they're trying to log in from someplace in Asia, you might say, that's not likely. They logged in 10 minutes ago from here in North America. So it's probably wrong. So you can use that. Now, I might point out that there are phone simulators. If anybody's tried to develop phone apps, you probably also try to develop it using a phone simulator. Yes, if you're developing an Android app, there's the Google phone simulator, probably the slowest program in the universe. But the phone simulator allows you to set your location. So you could be someplace else and set the location of what you want the phone to report. Okay, so there are alternatives to passwords. Let's try this breakout in a group thing again. Talk about the weather, or even if you're really good, think about at least a couple ideas how you can authenticate yourself to a computer without using a password. So I'm going to stop sharing. And let's give this a shot. All right. Any questions about what I'd like you to do? My question is, where did they put the button to break into groups? Oh, there we go. Sorry. Okay. Let's recreate the rooms. We'll. All right. And let's go for it. Come back in 5 minutes. Hello, have you fallen asleep, Shaver Smith and Justice? Woo-hoo.
Sorry, I have to do something. I have to leave.
Have to wake up. Yes. Oh, God.
Have a good afternoon.
Mr. Battle, I noticed you were all by your lonesome.
Oh yeah.
Yes.
They left once we got done discussing.
Okay. Yeah. All right. Okay. Yeah, I think I'll scare them up in 1 minute. I'll tell them everybody to come on back. That should be enough time. Okay, so they have 60 seconds. Here they come. Okay. Almost everybody's back except for people who had a hard time. All right. Let's just a second here. Let's see if we can't share the screen. There. Okay. Password alternatives. Hopefully some people saw some or thought of some ideas. What did we have? How about yes? Who's it? Oh,
Biometric.
yeah. Okay. What did your group do?
Oh, we said biometric.
Biometric. I got to spell today. Any particular biometric you like? There's several.
We said voice recognition. Well, I'm sorry, thumbprint. Biometric.
Yeah, thumbprints used in some phone systems these days. So that is becoming more common. Okay. Ooh. Anybody else? How about the Smith L? Yeah.
My group.
Yeah.
Sorry.
Mr. Hernandez, fire away.
For my group, one of the ways that we said was the two-factor authentication, where they'll send you like either through a mobile number or through your email a code of being able to log into the device into wherever you want to go.
Okay. Does that get around passwords? I mean, that's something you can do.
I have a question.
Yes. Fire
So
away.
is this focused on like websites? So put like password alternatives
Well,
for websites, or just like authentication in general?
Okay. Yes, and both, but the course is web security. So I was kind of hoping to stick to web, but a lot of these things are pretty generic and they might work better on devices other than web-oriented systems. In other words, they might work well on your phone, but not necessarily well on a general web.
Okay.
Although it's becoming easier to access some of the phone system capabilities from a website. So do you have something cool?
Not relatively cool. I was kind of thinking this was like based on general authentication. So I came up with stuff like smart cards, how you use key cards to get into places and stuff.
Okay,
But
well, those might be possible to get to. Okay, smart cards. How are we gonna call it one thing? Okay. Yeah. All right. How about the DeWitt Tamarana group? Anybody there? Nicholas Masaban? Oh, maybe they fell asleep again. Okay. Oh, how about the Shaver Ellsbury Brown group?
She put in the chat that YubiKey. If I don't know if you saw it.
No, sometimes the chat is hard to see on Zoom if you're sharing screens. So what did it say? When I get there, what does it say?
YubiKey. YUBI key afterwards.
YUBI. YubiKey. And what is a YubiKey for those of us who are ignorant?
Hey, Dr. Williams, it's Asha. I'm the one that dropped YubiKey in the chat.
Yeah.
It's like a RSA token.
Oh, okay.
It's
that
like
sounds...
Yeah, so RSAs are like outdated or whatever now. So a whole bunch of people are switching over to YubiKeys.
Okay. RSA is a encryption algorithm. All right. Yeah, that sounds good. I'm gonna have to look at that some more. Tell you there's many different systems used. Okay. Well, of course, I have some ideas. Tell you what, anybody else have some suggestions? Should we look at mine? But before we look at mine, let's take a break here. Oh, there's the chat. Yes. You can't chat and share your screen at the same time. Zoom doesn't like that. All right, but speaking of liking things, something you might like is results from the second exam. Yes, okay. All of you by now have got the summary of your grades. You all know how you're doing. It went well. Of course, there's the grading scale. I don't need to specify small numbers because nobody failed it. In fact, it was a giveaway. Look at that. 77% of the people got an A. I obviously made this exam way too easy. On the other hand, it took people a while. It took me an average of 4 hours and 15 minutes. That was the median. The median was 4 hours. That was way longer than I was, longer than the last exam. And some people told me I thought this exam was harder than the first exam. Well, it might have been harder, but people got to the answers. Now, one of the things that probably made it lengthy is all these crazy programs. I didn't ask you, how do you do this? I don't like the tell me what I told you type questions. I like the do something, show me that you can do something type thing. So I asked you to, hey, log into this system, do an SQL injection here, do a cross-site scripting there. And I had a program. Unfortunately, it takes a lot of time for me to write those programs. There were 20 different files involved in that exam from all the, yes, you got it. No, you didn't get it. Try again, sort of web pages and PHP programs in the back end. And I'll tell you, I'm not a very good PHP programmer. And maybe somebody can tell me someday how to debug a PHP program. I have not figured that out yet. Anyway, so I asked people, did you like the programs? Unfortunately for me, 75% of the people said yes, they really like the programs because that allows them to check their answer. One of the reasons people probably did really like, keep working on it until you get a good answer. I might point out that a bunch of people didn't get the first couple questions about XML correct. And there was a program out there to check your XML. It would have told you, oh, there's a syntax error in the XML. We took off points for syntax errors because XML takes off points for syntax errors. Some people's XML was not real good. In general, by the way, the XML question was graded by my teaching assistant. Finally get some work out of him. It's not his fault. I just haven't asked him to do anything. So if you think I misgraded it, let me know. I'll blame it all on the student, although I'm responsible for the grade. So if you think it's let me know and I'll take another look at it. Although I do happen to know on several occasions, my teaching assistant didn't catch things that I would have caught, right? Let him go. Also, I have to mention that I was sort of sneaky on that. And I asked you things like, what is your session ID? Well, when you logged into the web page stored your session ID in the database. So I could see if you typed in the same bunch of numbers that you did, which was the purpose, just to see. And of course, you log in multiple times, you get multiple sessions. What I didn't expect, but I did find, is that lo and behold, a couple people had the same session IDs, 2 different students with the same session. What does that mean? That means they must have logged in from the same computer on the same browser without closing it. Seems kind of suspicious to me. Maybe you think so too. Doesn't necessarily mean they cheated, but it did mean that they collaborated, that they were there together, probably spreading COVID, who knows. But please don't do that on further exams. That's doesn't look good. And remember, I've been learning a lot this semester about web security, and I'm watching. Okay, let's go back to authentication and see if we can't talk about that a little bit more. And give me a minute because the default configuration for this is bad. Okay, stand by for just a minute. Hey, sorry. Phone, it was my wife. And I've learned after many, many years, you ought to answer, even if you're in the middle of something. Okay, so enough of that. Let's share the screen here. Oops. Sorry, stop that button. Okay, that's, if I can click the right button at the right time. All right. What can you do besides entering passwords? And several of you have mentioned these things. One of the interesting things I've liked is a typing speed. It turns out when you type something familiar, particularly like your name, that you know how to type really well, that when you type it, the speed at which you type and the timing between your individual keystrokes is rather unique. Not 100% sure, but if somebody else types your name, it's likely not to have the same speed and keystroke intervals. So it's not, it can be used as a second level, a multi-factor login. Did they type the name correctly? And did they type it the way only you know how to type your name? Now, those who live in North Carolina may not recognize this, but I used to live on the far northern edge of this country where it got cold. I used to live in Minneapolis. It's cold in Minneapolis. You know, the high of that week may be a negative number. And when your fingers get cold, they don't work very well. It's hard to type. You'd never be able to type in the same way you usually do. But that's enough. Okay. Other ways, other systems that might work, draw a squiggle. There was a researcher at A&T, one of the graduate students was working on a project just for that. They asked the students, just wiggle your mouse around, wiggle the mouse around in a way that you can kind of remember how you wiggle it. Well, it turned out people tend to wiggle in a unique way. And so it was not 100% sure, but again, it gave you a probability that this was or was not the correct person that you use in multi-factor authentication. You could have them log in and then wiggle their mouse. You keep track of where the wiggle went, and you can match it against their favorite wiggle. And you can say, yeah, that's pretty close. It's probably them. Other ways are paint a picture with the mouse or your finger on the screen. Just draw, in other words, you've previously decided what the picture is that you're going to draw, a smiley face or a house or something or a cat or whatever, and then when it comes to login, you draw the picture, which you know how to do and somebody else does not know how to do, and that can be used. Another interesting one is pick a color. Say your favorite color is green, and then it shows you a picture, usually a different picture every time, and you point to something that's green. And the computer says, oh, yeah, the color is green. They point at the green area of the screen. That works. And of course, you can go through all sorts of pictures as long as the pictures have all the colors that a user is allowed to choose. Now, the problem with that is there's not that many pictures, or excuse me, not that many colors that humans can easily distinguish. You can green, aquamarine, is it Kelly green, forest green? But anyway, it is a possible solution, and it's not involved entering a password. Another system that requires much more mechanical equipment than you would find in a web application is watching your eyes. They call it gaze-based system or eye typing. In other words, you look at where the people's eyes are pointed. this happens all the time in Zoom. They're looking at their email or looking at their phone. Where are they looking? Well, if you can look carefully at their eyes, and then when it's time to log in, you have them look here, there, here, in a particular pattern. You look at the eyes and say, yeah, they followed the right pattern. And for a human being, it's kind of hard to look at someone else's eyes and do that very quickly. So that was an interesting way to log in. Biometrics is mentioned. There are a whole bunch of biometrics. And again, I just mentioned behavioral biometrics, keystroke, voice recognition. You saw Edna Mode use a whole bunch of these. Again, there's face recognition. At A&T, several graduate students are working on face recognition. Fingerprints, very common. Apple phones use that, and Android phones now can use fingerprints. Whole hand prints, that's bigger than the finger. Iris can be used. You have to look really carefully. And then DNA, yeah, but that's kind of tricky. Works in the movies. And again, as I mentioned, fingerprint readers are pretty simple. I've got fingerprint readers. For years, I used to use a fingerprint reader at A&T when I logged into my office computer. It was interesting is that I was not doing research in biometrics, even though several researchers were. They were not using biometrics themselves. And I was the only one using biometrics, but I wasn't researching that area. What I did learn is that after a while, my fingerprint reader became less reliable. I had to be able to orient my finger. I had to reinitialize the fingers. In other words, it didn't like my fingers after a while. So I go, okay, forget that. Let me reinitialize, type, ask you to type, rub your finger over the fingerprint reader a couple dozen times and it goes, yep, I know who you are. And then it would work again. So I'm not exactly sure why that was true. Also, some people's fingers just don't work very well. Some people don't have very pronounced ridges on their fingers, and therefore it just doesn't work. Also, again, the weather can have an impact on that. When the weather is very dry, if it's sometimes in the winter, the indoor humidity goes very low and you don't have very good fingerprints. I might note that Microsoft has the Windows Hello system that has multiple ways to do login. One of them is fingerprints. So you can automatically use fingerprints for logging in. And of course, the finger doesn't have to be attached to the hand. Turns out it's not all that hard to forge fingerprints because you leave them everywhere. You touch something, you leave your fingerprint, the FBI knows that. And it turns out that people have been able to fake them. There's the gummy bears. Yes, you see my gummy bear collection there. There is the gummy bear technique for copying fingerprints. You can Google it up sometime and find out how to make fake fingerprints with gummy bears, but it's doable. And so somebody can make fake fingerprints, put them on rubber gloves, and then just go to the system and log in as you with the fingerprint because their rubber glove fake fingerprint will look like you. Of course, 3D printing allows us to do wonderful things. I mentioned iris matching. That was a real popular tech research area at A&T. When I went to my eye doctor one October, they had all sorts of fake lenses that you could put in your eye, contact lenses. You could get contact lenses that look like cats or other things on them. And of course, if you wear the fake contact or the contact lenses with fake eyes, your iris matching is just not going to work. And it works pretty well. Again, some people want to use recognition. Now there's recognition and authentication. They're two similar but different concepts. Authentication, which I've been talking about for the last hour and a half, is the idea, are you who you claim to be? Recognition is, who is this person? And some people want to do facial recognition. The FBI would like to take pictures of crowds and be able to find the bad guy in the crowd. That's recognition. Authentication is you claim, you identify yourself to a system, and then it tries to validate that you are you. Well, it turns out authentication is significantly easier than recognition. there are a bunch of problems with biometrics because if somebody learns your password, oh, you changed your password. What if somebody copies your fingerprint? And again, as I mentioned, they're leaving them all over the place. How do you change it? It's very difficult to change your biometrics. Now, turns out that biometric revocation is a research area and people are working on that issue, but it's difficult. You can't change your fingerprint. Okay, that's it for today. I probably bored you to places. So wake up. We only have a few days, a few weeks left. Next week is April 6th. And if all goes well, I'll be talking about denial of service and open source. Those are in the textbook. Please, if anybody actually ever owns a textbook or reads it, take a look at that. If you look at the syllabus, the appropriate chapters for that are out there. And then I've added a lecture on cloud security that wasn't originally there, but the department told me that I should lecture on cloud security in this course. Oh, okay, wish you told me earlier. And then in 3 weeks from now, we'll be having the third exam, then another class to review for the final exam. Now, yes, I know there's 2 exams right next to each other, and I'm aware of that. But remember, the more exams you have, gives you the ability to screw up on one and still get a good grade.
I can't do nothing past that motherfucking 50.
Excuse me? Okay, well, and after the third exam, sometime before the review, I will again send you a summary of your grades, and you might be exempt from the final exam. The exemption rules are in the syllabus, and we will talk about them as it gets closer, not until then. I might also note that, if the world changes and something happens, or I think of something better than this, well, I'll change it, but I'll try to let you know. But for right now, next week, denial of service and open source software attacks. So look at those in the book, and I will be looking at them myself, and that's the topic for next lecture. Please take a look at the Kerberos pre-recorded lecture. All right, does anybody have any questions?
I have a question about finals.
I'm sorry, I couldn't hear you.
I have a question about finals.
Yes, what about the finals?
Is it about all the syllabus? Like
Oh,
whatever?
the final will be about everything you ever learned and more. Yes. Yes, the final is cumulative. Now, do not despair. There is a possibility that you might be exempt. Oh, yeah, Dorian's already asked me how you get exempt. Okay. It's in the syllabus. You are exempt if it is statistically unlikely that the final exam will change your grade. What does that mean? Okay. If we get down to you've taken all the assignments, all the exams, and you'd have to get a grade on the final exam that's way out of range from what you've received so far to change your grade. The final accounts for 20% of the grade. But let's just give a hypothetical that going into the final exam, you have a 99% average. You've done really well. Well, you might have to get like a 46 on the final in order to drop below an A. Well, somebody who's got a 99 average is not going to get a 46 in the final. And so why bother? They don't want to take the exam. I do not want to grade the exam. And so we just skip it. But I will determine if it is statistically unlikely. And that's why we have spreadsheets and grades and stuff like that. So I will let you know after the third exam, if you've handled all the stuff, whether you've met the requirement. And of course, it's different. It's not just like, oh, you have to get a 90 and above. No, it's more complicated than that. It may be you're in the middle of a B, and there's just no grade you're likely to get that's going to get you out of a B. So just take your B and go. Now, at any time you are exempt from the final, you are always allowed to take the exam to see if you do better or worse. But hey, that's what, a whole month away. The final exam is whatever I said it was, May 4th.
4th, yeah.
May 4th. It's also, by the way, at the same time as the class starts at 2 o'clock, 2 to 4. It's a 2-hour exam. And I don't know what the format of the final exam will be. Yeah, but that's light years away. I haven't thought about that yet. I don't want to have to build a whole new system, so I'll try to make something simple. Okay. Any other questions about more near-term things? If not, see you next week. Please read about denial of service and yeah, whatever else the topic is. Yes, okay. Open source attacks. It's in the book. Next material. Okay. See you then.
Okay, thank you, Professor.
Have a good week.
Okay. As always, if you have a question,
good week,
problem,
Dr.
contact
Williams.
me. See you later.